So welcome to the first set of SPSS videos produced for basic social statistics in the Sociology department. Basically a set of videos to help undergraduates maneuver SPSS, which is the program that you use to do many of the assignments for this course. And although SPSS is a relatively easy program, it's mainly just point and click. Sometimes the already high level of anxiety that students have with statistics make learning SPSS somewhat of a chore when it really doesn't have to be. So we created these videos to make life easier for both the TAs and students. And so we're going to start at a very basic level and hopefully give you useful information on how to use the program. Each session we're going to outline what we're going to cover, and I should also say that these videos are intended for undergraduates. Graduate students can of course use them, but we don't cover syntax. So if you want the syntax, you should look at the SPSS videos for intermediate statistics. So in terms of opening up SPSS, it's actually relatively easy to do so. You can just go to the Start menu is one way to do it and find the program. If it was recently started, it'll be right there, or you can look it up on the All Programs submenu. Go to SPSS and start there. Another way to start the program, like you can start most programs on Windows, is just to find a particular data file. So just like if you're starting up a Word document that launches Microsoft Word, same thing applies to SPSS. So a data file that you'll be using a lot in this class is the GSS 2006 data file, and if it's an SPSS data file, it'll have a little icon that looks like SPSS, and the ending of the file will be a .sav. So if I were to simply double click on this, it would open up this data file and launch the program at the same time. For this first video, we're going to show you some basic things. So we want to open up a blank data file. So we're just going to open up SPSS this way. So when you start up the program for the first time, this intro window will pop up, and from here you could run a little tutorial if you like. It's pretty helpful, but it's a bit long. Another option is just to type in data, which is what we're going to do. And then there's other options if you want to open up, for instance, an existing data source. You can find where the GSS file for your class may be located, and you can just upload it from here. So we're going to type in the data. That's the most convenient thing for us right now, so click OK. And one of the most basic things to familiarize yourself with SPSS is that there's several different views and windows that the program uses, and you can tell what view and window you're using if you look at the bottom left of the screen. There's going to be some tabs, and right now you can see that I'm looking at the variable view, and alternatively I could click on the data view. There's also an output window as well as a syntax command window, though we're not going to cover the commands in this class. Just in terms of the data view, this is where the actual data would be, and if you've used Excel before, it'll be somewhat similar to you. It looks like an Excel sheet, and basically if you're going to add variables here, you would see that the variables go horizontal, and cases, observations, or individuals go vertical. So for instance, this could be one respondent of your survey, and this would be the first question. And let's say that we were sampling the class in terms of SAT scores, and we asked somebody named Tom what their score was, and Tom got a 560 on the math portion of the SAT. So we just type in 560, type enter, and we see that SPSS has generated a new variable name. If we go to the variable view, we'll see now we have a new variable, whereas before there wasn't. We can change this name, and we'll do that in a second, but let's go back to the data view here. We can sample more people. Let's say that we talked to several different other people and they gave us some other scores. In 250, I'm not sure if that's possible. Let's say that somebody got a 750. And let's say we're also interested to see if there's an association between SAT scores for math and how much people actually like math. And let's say that we had a survey question where we asked people to rate how much they love statistics. And let's say it's a 1 through 5 type of question, where 1 means they absolutely hate statistics and 5 means they absolutely love statistics. So let's say our first person, Tom, loves statistics, even though he didn't do very well in it. And we just give him a 5. This other person, doesn't love it so much. This person is so-so. This person really doesn't like statistics, and this person, even though they did really well, they hate statistics. And let's also just create another variable while we're here for gender. Let's say that 1's equal male and 0 equals female, and that's kind of arbitrary, but we could have made it the other way. But so let's say that Tom is 1. This person maybe was a female, this person was a female, and then the last 2 are males. So we have here just a collection of data. Here is the first case or set of observations across 3 variables. Tom got a 560 on their SAT score, really loves math, and is male. We can actually give these numerical numbers some values, and to do that we can just look at the variable view, and one of the first things we can do here is just change the name of the variables. These aren't very original names, so we can just say, instead of variable 001, we can call it SAT _ math, and to do that I just clicked on it and typed. Here we could just call this like math. And one thing to note here is that for names you can't have spaces. So if I were to write like math, it's going to give me an error message. And there you see the error message. So I just click OK, and I just have to give a name that SPSS likes, and it's just one word, like math. And then the last variable, let's just say it's called sex. We won't talk about the type or width or decimals, but we can look at the label. This is kind of what's the label of the variable, what does it actually signify. You can make it a little bit bigger if you wanted to, and usually for surveys you'll have maybe the actual question that was asked. Here we can just say SAT math score. Type enter. This one we can just do the actual question, so maybe how much do you like math? And the last one is the sex of the respondent. Sex of R, sometimes you'll see these types of labels. And when you're done making the label of the variables, you can actually then assign values to the specific numbers that are represented in the variable. So to do that, you just go to the values column and double click on one of the variables that you want to change, and the little pop-up window comes up. And so for sex, I believe we said that 0 equals female, and to do that just type in 0 and type in female as the label. The other value you want to assign is males, which is 1, I believe. So 1 equals male, and you just type it in, and when you're done you just click that add button. And it's important they actually click the add button, because it doesn't do anything. SPSS doesn't assign the number values unless you actually click on add. And if you made a mistake, you can just always click remove. But I don't think I made any spelling mistakes there. Click on add. And you can do the same thing for the other variables. So for instance, the how much you like math, I believe 1 was really hates math. And so forth. And when you're done assigning all the labels that you want, you just click OK. And if you go back to your data view, one thing you can do to check to see if everything is being translated right is that if you have this little button clicked, this little $sign clicked on, you'll see that the values that you assign are laid out on the data view. So you can just switch back and forth. You're not actually changing anything, you're just changing the view. One other thing you could do, though it's not necessary, is to also indicate what kind of variables these are and how they're measured. So for instance, you'll notice that I actually didn't label the values for SAT Math, and the reason is it's because the scores are kind of self-evident. 750 is a 750. It's also a continuous variable, so there's a couple assumptions built into that. One of them being that you can measure the distances between numbers forever. They can get smaller and smaller, and so that's in the language of SPSS, it's called a scale or a scaling variable. There's also assumptions built in about the ordering of the numbers, and also that the intervals actually have a meaning to them, as opposed to discrete variables or categorical variables, like the question we had, like math. Even though we can think of it in terms of a scale, they're discrete measurements, in that a 2 means something very specific, and a 3 means something also very specific. And even though there's an incremental nature to them, that as you go higher in the scale you like math more, there's no such thing as a 2.5. The distance between a 2 and a 3 may not mean the same thing between a 4 and a 5, for instance. So we don't know what a 4.5 means. You can tell the SPSS has a little cartoon that kind of helps you out with that. So that's called an ordinal variable. And then we have a nominal scale, also categorical and discrete. It's dichotomous in that you can either be one or the other. And also there's really there's no real assumption about the ordering of the variable. Like I said, the scaling variable, there's an assumption about the order and the interval. The ordinal variable, there's an assumption about the order, but the nominal doesn't really even have that assumption. We could have said that females are 1, or males are 32, or females are 65 and males are 0. We tend just to label 0 or 1 for other reasons, but the numbers, the distances between the numbers and the ordering of the numbers don't really matter. So it's considered a nominal variable. And once you have that done, you can then move on to the analysis. And to do analysis in SPSS, you just go to the menu bar, and you'll see that there's a variety of different things you can do. Some very simple, some very complicated. We'll start with something very basic. We'll do a descriptive frequency. And so we just go and highlight frequency. And you'll see a little pop-up window. This pop-up window comes up for most of the analysis that you run, and they're very similar in that you will always have your list of variables on the left. So all the variables in your data set. So we have sex, like math, and SAT math. And on the right side is the variables that you're actually going to choose to run an analysis on. So we're wanting to run an analysis on math, so we just move it over. That little arrow tells me now that this is the target variable. And if I made a mistake, and I can just move it back. I want to do an analysis on sex, like math, and SAT score. And we just click on OK. So another document opens up, or another view if you want to consider it as such. It's called the output document, and basically tells you several different things. One, it provides you a log of what you're doing. This output document you can actually save maybe on a flash drive, and you can keep track of your work. On the output window itself, it tells you the command that you ordered the program to do. We're not doing syntax commands in this class, but if you had, this is what you would have typed in. And so this is just giving you a record of what you did. And then it actually gives you the analysis in terms of the outputs themselves. You may have graphs, you may have tables. Here it's telling us that we ran a frequency on these 3 variables, and these variables each had 5 observations that were treated as valid, and 0 were treated as missing. We'll talk about missing values in another video. So for instance, we have a frequency here of 2 females and 3 males. This is the count of people in your sample that were female and male. This is what these numbers correspond to in terms of percentages, as well as valid percentage. We'll talk about that as well when we talk about missing values. And then it gives you a cumulative percent, which really isn't that relevant at all for this type of variable. But if we look at something like SAT math, we have the frequency as well. So we have one person who had 250. That constitutes 20% of the sample, and it constitutes a cumulative 20%. And what that tells us is that 20% of the sample scored a 250 or less. Similarly, at 560 also constitutes 20%, but here the cumulative percentage tells you that 60% of the sample scored 560 or less. So cumulative percentage is a helpful tool when you want to look at the median or the mean and stuff like that. We'll talk more about that in future analysis, or future videos. But that's about it.